Math 8, Unit 6, Pythagorean Theorem and Real Numbers, Lesson 5, Part 2, the distance formula. So if we are to find the distance between -2, 3 and 6, -3, what we have done historically with this is we've drawn ourselves a picture, maybe on graph paper. It doesn't have to be. It can be kind of rudimentary. We create a right triangle by figuring out the change in x, which in this case is 8, and the change in y, which in this case is 6. Then we set it up using the Pythagorean theorem, treating a and b as your 6 and 8, and then the c as your d, distance. And then we can solve this if you square root both sides, and I flipped it around, and then do some simplifying, you end up getting a length of 10 units. Now the distance formula is pretty much going to be what you see here, that main idea of the distance equaling the square root of the two legs of the triangle squared and added together. Of course, we're going to do it more rigorously than that. Let's take a look at this. So if we've got 2 points that have some distance between them, we can draw them and then make this little right triangle. And then we need to consider what these are. From the top to the bottom of this, so this leg of the triangle ends up being y2 minus y1. And the distance along the base of this triangle is the length between the x's, which is x2 minus x1. Now we can set this up using the Pythagorean theorem, that x2 minus x1, which will be the length of that side, squared, plus y2 minus y1 squared will end up equaling our distance squared if we use d for distance. Now simplifying this down, let's put the d first, but we're going to square root both sides. D equals the square root of x2, oh, I meant to do that in blue. Let's try that again. x2 minus x1 squared and y2 minus y1 squared. This is the distance formula in all its glory. Now I do have a simplified version of the distance formula that I will often use. Using delta notation. Delta x, meaning the change in x, is x2 minus x1, and delta y is y2 minus y1. This can give you a simplified distance formula of the square root of delta x squared plus delta y squared. And the nice thing is you can get these delta x and delta y from your past learning. We learned that the slope is change in y over change in x. So you could, if you wanted, pretend you're finding slope, and then once you get those two numbers, the top and bottom, the rise and the run, don't do any reducing, but go ahead and plug them right into the simplified distance formula right here. So I can use the distance formula to determine the distance in the coordinate plane. The distance d between any 2 points, x1, y1, and x2, y2, is given by the formula d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Or if you use delta notation, using delta x to be x2 minus x1 and delta y to be y2 minus y1, then the distance equals the square root of delta x squared plus delta y squared. Let's take a look at it in a situation here. Let's find the distance between 1, 5 and -4, -2. First, if you just apply the distance formula and plug in your x's into the first set of parentheses and your y's into the second set of parentheses, a lot of calculators will let you type that whole thing in. And if you do type that whole thing in, which I encourage you to try, you will end up getting 8.602. It does keep going after that. and you'd round it to whatever you are needing to. The alternative method here, if I take the points 1, 5, and -4 and -2, and think about the distances between the x's, the distance between 1 and -4 is 5. The distance between 5 and -2 is 7. We can take 5 and 7 and plug them in to the simplified distance formula, and we get the same answer here. This ends up being the square root of 74, which is approximately 8.6. So we get the same answer there. Another thing that some students like to do here is pretend they're finding slope, so you can do your difference quotient. You can fill the y's up on top and the x's on bottom, and you can find your slope of 7/5 without reducing that, which it doesn't reduce anyway. You can take this 7 and this 5 and plug them in to the distance formula as your rise and your run, and you can find it that way. Okay, let's find the distance between some more points here. On number 3, this is going to be the distance between 4 minus 0 squared plus 5 minus 0 squared. Or if you had found the distances, the distance between 0 and 4 is 4. The distance between 0 and 5 is 5. And you can type that in instead. And this does give you 6.403 as your distance. 6.403 units. Okay, the distance between 7, -3 and 9, -6. Using the full distance formula, we can just do 9 minus 7 squared and then add to that 6 minus -3 squared. I change that to plus before trying to type it in your calculator. Now, you can also do the simplified distance formula. The distance between 7 and 9 is 2. The distance between -3 and 6 is 9. So this ends up being 9.22 when you square root that. Units. Okay. Next one, we can do the square root of -2 minus -5 squared plus -3 minus 1 squared. And this ends up giving you 5 when you type it in the calculator. We can also do, well, with the negatives here, it's probably a good idea to go ahead and think in terms of slope. So this would be 1 minus -3 and -5 minus -2. And this gives you basically a slope of -4 over -4 over -3. Now the negative can be plugged in to the simplified distance formula, because when you square a negative, it comes out positive anyway. And knowing that, you could actually save yourself some time by just using 4 squared plus 3 squared and square rooting that. It'll give you the same answer. But that's just off of the understanding that when this gets drawn, instead of it being up 4 back 3, we just treat that as a 3 and treat that as a 4, and we're good to go. Alright, let's determine the distance between these two points that are much further apart. Now, because we have the access to a calculator, the calculations aren't really a problem. We just do what we regularly do. But I'm going to plug it into the regular distance formula. Let's do -48 minus 55 and square that. And then we'll do 90 minus 31 and square that. Now I'm going to type that whole thing into my calculator. -48 minus 55, square that, and then we're going to add 90 minus 31 and square that. And I get 118.701, but we'll round that to 118.7 units. Now, you could also use the idea of slope to get the changes. Maybe I would do 90 minus 31 and negative 48 minus 55. 90 minus 31 is 59, and negative 48 minus 55 is negative 103. So I would use those two numbers. And yeah, I'm putting delta y first, but that'll be okay. And if I type that into my calculator, again, I don't have to keep the negative in front of the 103 because when I square it, it's going to be positive anyway. I get the same 118.7 units. All right, quick preview on the assignment. On number 1, you are going to be using the converse of the Pythagorean theorem to determine whether each of these 6 triangles are right triangles. On number 2, you'll use the distance formula to find the distance between the set of points. Number 3 is a review of finding slope. 4 is solving a proportion. 5 is a situation problem with a diagram not drawn to scale. Try to figure out which plane is closer to the base of the airport tower. You will need to know this conversion rate, that 1 kilometer is about 3,281 feet. Number 6, determine the measure of the interior angles of this triangle. Remember the angles in a triangle add up to 180. 7 is a matching task where you try to match up these 3 statements with whether it's acute, right, or obtuse triangle. And then on number 8, you'll use that information to find out whether the triangle created by these 3 coordinates is acute, right, or obtuse.